Welcome back, Science 10. The last two labs in MW4 deal with acceleration. So there's a Part 1 acceleration lab and there's a Part 2 acceleration lab if you choose to do it to achieve that higher level in the contract. If you look at acceleration 1, what you're going to do is to predict what the distance versus time and the speed versus time graphs look like for something that's uniformly accelerating. Okay, so we haven't talked about speed time yet, graphs yet, so you're going to have to predict. So predict the shapes of a distance versus time and a speed time versus graph. Now, before I do that, we should likely go down and see exactly what you're going to be doing. So we're going to be using the motion detector, the iPad. The 2x4s will be set up on an incline, as you can see here. So we have an incline, we have a 2x4 going down. Motion detector, you have to excuse the crummy drawing here, and you're going to be rolling this supposed 15-pound weight down the 2x4. So it'll be rolling down and the motion detector will be detecting its motion, and of course it will be accelerating. Just like Galileo did to slow down the effect of gravity, put something on an incline, it speeds up, it accelerates down, but it does in a slower rate so you can actually measure it. So what would a distance time graph look like? And what would a speed versus time graph look like? So that's what you're going to predict there. You should be able to figure out the distance time graph from the experience you had with the earlier sections. But a speed time graph, think about what happens to speed as it accelerates down the plank. What will that look like? Over here, just simply define what acceleration is. So look back in your notes. And as we mentioned before, this is the setup we're going to be doing, just simply releasing a weight, starting the motion detector. And you may have to do it once to get a distance time graph, then do it again with the settings on speed versus time to get both of those types of graphs. And then in the data table, so as you actually do the experiment, just kind of sketch the shape that you see in the iPad. So nothing too extravagant, just kind of I'm more concerned about what the shapes look like. What does the distance versus time graph look like, and what does the speed time graph look like? Were your predictions right? Then of course, as usual, what we have in the conclusion, what we're going to do, the purpose was to, well, you can go back and look at the purpose. It was thought that, so you could describe the two shapes of the graphs that you thought would happen. Then of course what did happen, you'll likely talk a little bit about what happened up here. Was it close to what you thought it would be, or is it completely different? Okay. And then lastly, two questions here. Predict the speed in meters per second of the weight by the time it hits the floor. So by the time that weight hits the floor, how fast is it going? How many meters per second is it going? So you'll likely have to redo the lab and just easily get a speed versus time graph, and then look at the particular part on that graph which represents when that weight has reached the bottom of the 2x4. Okay? And then B, determine the actual, so predict the speed first of all in meters per second, and then actually do it. Determine the actual speed by releasing the weight as before and using the resulting speed versus time graph. So the first part here, 1A, predict how many meters per second that weight is going by the time it hits the floor, and then B, actually figure it out and see exactly how close you are. So that's the first little activity you're doing there, the acceleration lab part 1.